Hello everyone, welcome to the next lecture on the directional derivative. Today we will discuss about what are the directional derivatives and its example. We will solve the 15 examples of each of the different kinds so that you may understand all those concepts in this single video. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute. You can simply follow my YouTube channel Dr. Harish Garg and its the various videos and the playlist Mathematics 1 related to the change of the order, volumes, area and so on. Now what we have seen in our last lecture, that is the chain rule and the partial derivative. This is the rate of the change of the f with respect to the x, keeping y as a constant. What is the meaning of that? It will give you the rate change of the value f in the direction of the x-axis. Similarly, if you compute the partial derivative with respect to y, it will give you the rate of the change in the direction of the y-axis. So it means this will give you the only rate of change in the one direction. Here this is the only rate of change in the y-axis. But what is the target of this lecture is, we will see or we will learn how you can find the rate of the change at any point. Like if you have this instead of this is nothing but my change in this is my change in here. But if you find the point P, which is nothing but x0, y0, then what is the rate of change of this point P in the direction of, say, this is my u. This is my u, then how you can find the rate of change of this function with respect to this point P. Or you can say how you can generalize the partial derivative in terms of the any direction of the slope, because this is only on the x-axis, this is only on the y-axis, so we can change them to be any of the direction is called as the directional derivative. So how we can define this directional derivative? So firstly, as by the definition, we will try to expand into any of the arbitrary direction. So it means the partial derivative of the x and y are the particular case. What is the meaning of that? If I just consider only on this u is my here, that is along the x-axis, then the directional derivative is nothing but my partial derivative with respect to x. On the other hand, if I consider this u as only of u2 of j cap, that is on the y-axis, then we will give as a partial derivative with respect to y. How you can define the directional derivative? So there are the two things which we need them. The first one is the gradient vector, second is the direction of the vector. What is a gradient vector? So the gradient vector of any of the function f is denoted by del of f or the grade of f, which is defined like here. What is the meaning of the gradient is, it is always point the directions in the greatest increase of the function. And how you can find the direction? If I say u is the any of the direction in say r cube, then how you can find the direction? The direction is nothing but my u over mod of u. So that is my here. So we all knows how you can compute them. This is here. Or in other word, what is the direction of this? It is nothing but called as the unit vector. So we know how you can write the unit vector is u cap. So that is a u cap is a unit vector. So once is a unit vector, the length will be my 1. Now based on this gradient vector and the direction of the vector, we can define the direction derivatives, that is the rate of the change in the direction of this u. What is the meaning of this line? That is nothing but my u of a cap plus b of this. If there are the 3 dimension, then you can write as a c cap. Then the directional derivative is denoted by duf, and it is defined like this. That is nothing but the partial derivative. You can see these the partial derivative are there. But here the most important thing is, if you fix in the direction of here, if I just consider it, the initial point is my here, what is the meaning of that? You can change them to the chain rule. If you apply the chain rule, you can here. What is the value of this? You can compute from here. What is the partial derivative with respect to x is a. Partial derivative of this with respect to s is my b. So this value is my a, this value is my b. So I can substitute here, this is. Can I write this value in terms of the two values? I can write this as a cap plus of b cap, and I can write this. So what is that? This is nothing but my gradient of the f. What is that? This is the vector u. So it means the directional derivative is nothing but the dot product of this gradient vector as well as the unit vector. And if you want to find at this particular point, then we can find the gradient at the particular point and the directional derivative here. What are the properties of the directional derivatives? It clearly says that it's a dot product, and you know what is the a dot b. This is nothing but mod of a mod of b cos of phi, where phi is the angle between A and B. So again we can write like here, where phi is the angle between the gradient and the unit vector. Now here we all know that u cap is a unit vector. So what is the absolute value of this? This is always be a 1. So this value is my 1. Now from here, but you can say that when it will be the maximum, you can see when this will be maximum, the maximum will be my 1. When it will be 1? When it's a 0 or 2n pi. So when cos phi is maximum, it means that directional derivative is my of here at the point P0. When the cos phi will be minimum, cos phi is a minimum is my -1, or for what value of the phi, the cos phi is -1 is my pi, and here. So what is the meaning of that? It means the unit vector and the gradient vectors are moved in the same direction. What is the meaning of the pi or 2n plus 1 pi? When this is my odd number, then it means they are moving in the opposite direction. So what is the value of the directional derivative? This is nothing but my minus of here. And what will happen if my phi is my 90 degree? That is my cos phi 0. So it means there is no change in the direction of this. Now what is the meaning of that? How you can solve this one in your examples? So let's say we will discuss about the 15 examples of the 7 different categories. We can solve this within a fraction of a second in each problem. So let's start with this one. You have to find the derivative in the direction of this. So this is in the R2 plane. It means your target is to find the direction derivative. So our target is always to find this and the u cap. Once we know these two values, we can substitute here. How you can find the direction? This is a gradient vector. This is my f. You can take the derivative. Add the point this. Now you can substitute this value at here. You can get this value as gradient of p. If I consider this as a p0, then if I consider this as a p0, then its value is my here. How you can find the u cap? We all know that u cap is nothing but my, because this is already a unit vector is given to you. It means this is already a u cap. Now once you know the delta, gradient, you can substitute them here. What is the derivative? What is the dot product of this? Is the right answer. Look at the another example. Now again you have to find the derivative. It means your target is to find here. What is the partial derivative of this with respect to x? It's a 2y. What is the partial derivative of this with respect to y? It's a 2x minus of 6y of j cap. Now you can substitute at the point P0. We can get this value as here. Now since it is not the unit vector, so firstly you can make them. How you can make them? This is 4i plus 3j divided by 4 square. That is a 16 plus 9. That is nothing but my 5 is the answer. Now you have the dot product of this and this, you can substitute here. You will get the right answer as -4. Look for the another one. You have to find the derivative of this function. Now it's a 3D in the direction of this. Again your target is to be here. Now here this is a 3 dimension. You can write in this manner. What is the partial derivative with respect to x? It is nothing but my 2x I cap. Partial derivative of y is 2y, 4y. This is 6z of k cap. Now you have to find the value at the point of 1, 1 and 1. What is the gradient of the f? It is nothing but my 2i cap, 4j cap and the 6k cap. Now once you can find here, find the unit vector. Since it is a vector given to you, so what is the value of this? I cap, j cap, k cap divided by 1 plus 1 plus 1, that is the root 3. So you can say it's my here. Now you can make that dot product. So what is happened? 2i of I is 2, 4 minus 6 over root 3. That is my 0 is the right answer of the problem. Now look at the another type of the questions. Now in this case you can see the direction vector is not given to you. So what is that? You have to find the directional derivative. Again your target is to find of this at the point of P. So our first target is to find the gradient and then u. But here you can see u is not given to you exactly, but this is in the line of PQ. So u is my PQ over this. How you can find the PQ vector? So we all know that this is the position vector of Q minus position vector of P, or you can say the direction ratio. So what is that? P is my 5, first coordinate is my here, plus qy coordinate, py coordinate 0 minus 2, and the third one is 4 minus 3 of k cap. So this is my here. Now once you know the u cap, so can you find this value? This is 4i cap minus of 2j cap plus 1 of k cap divided by 16 plus 4 plus 1. So that is my 21 is there. Now once you know the u cap, now your target is to find the gradient of f. So it's a 3 dimension. You can write in this manner. So at this point p, you can find this value. So you have this value, you have this value, you can multiply them, you will get the gradient of here. Also the second part is in what direction it will be maximum. So we have seen in that what is the direction of the maximum is when it will be here. So f is increases most rapidly in the direction of this here. If they are talking about the decreases, that we will see in the next example. So what is the direction? So they are talking about the direction. It means you have to find the u cap in the direction of this. So it is my here. What is that gradient of f is given to you here. You can substitute this value, you can get here. So you can see I can write for you here 2i cap minus 4j cap plus of 2k cap. What is the absolute value of this? It's a 4, 16, 144 is the right answer. And what is the derivative value? That is the maximum derivative value is my plus of mod. So it will be of here. 4, 16, 144 is the right answer of the problem. Look about the another one. Now you can see in this is another type. In this case, you have to find the increase, you have to find the decrease, and the no change as well. So first of all, you have to find the directional derivative. Again, the directional derivative is my this rule u cap. So firstly, you can find the gradient is a 3 dimension of the function here. So what is the partial derivative? It is my xy. With respect to x is my y. So this will be cancelled out. It's a 1 by x plus 1 upon zx of z. So it is my 2 by x and so. At this point p0, the gradient is my here. Now this is in the direction of this. So you can find the value of u. Now you can find the directional derivative as here. Now the second part is how you can find the increase or decrease. So as I discussed in the previous example, f increases most rapidly in the direction of the plus gradient, f decreases most rapidly in the direction of minus of gradient. So now look about that, they are talking about the direction. So what is the meaning of this direction? That is gradient over mod of f. If they are talking about the minus, so it means minus of gradient over mod of f. So that's a simple answer of this. So what is the gradient of f? It is my here. So if I substitute this value, this 2i cap, 2j cap, 2k cap divided by 4 plus 4 plus 4. In this case, it's a minus 2i cap, 2j cap, 2k cap divided by minus 2 square is plus 4, minus 2 square plus 4, minus 2 square plus 4 is the right answer. So since it's a positive, similarly you can find it is a negative. Also they are talking about the find the directional derivative value. So what is the directional derivative value? Since it's increases, so it's a modulus of this, and it is a decreases, it's a minus of gradient of this. So you can see the direction value is mod of gradient f, that is my 2 root 3. What is the decreases case? It's a minus of root 3. Okay, what is the no direction? So what is the meaning of the no changes? It can be, that means you have to find that, because you can see this is my gradient, so it will be my here u cap cos of phi. So when it will be the no means 0, when it will be 0, when it will be a pi by 2. So it means you have to find the any of the direction whose dot product is 0. Rate of the change of the f is 0 in the direction of this. So firstly we can find the direction of gradient f, that is my say u1 we can find here. Now your target is to find any of the vector u2 such that u1 dot u2 is 0. So you can consider any one of them. So say 1 by, you can say if I consider I plus j minus of k. So what will happen if you consider here? It will be my, and you can consider any of the number, for example here. So what will happen? What is the u1 dot u2. So it will be 1 by root 18. It will be my 1 plus 1 minus of 2. Is it 0? Sorry, yes. Is it 0? Yes, it's a 0. It means u2 is the direction in which there is no change in that. You can consider any one of the others. So since this one is a 0, so it is an orthogonal whose rate of change is non-zero. So remember that this is not a unique vector. There are existing of so many are there. Look what the another, again similar type of the questions are there. So we can firstly find the gradient of this f and at the point 0, 0, 0. So what is the value at the 0, 0, 0? So gradient of f, e of 0, 1, cos of 0, 1, so it's a here. Z is 0, so it's a complete 0. Y is 0, so complete 0 of this. So gradient of f is my here. Now you have to find in the direction of this, so you can find the u cap. Now in this case they are not talking about the direction derivative. So if you want to find the direction derivative, you can find this value as u upon here. But they are simply find the direction in which function is increases. It means we have to find here. What is the answer of this? That is my here. You can substitute the gradient. That is nothing but my 3i over root 9. In this case it's a minus of 3i over 9. So that is my I and minus I. And they are not talking about the value. So if they are talking about the value, what is the value of in the most increases gradient of f? That is my 3. In this case it's a minus of gradient f is my value is my minus of 3. What is the meaning of the no change? So they are talking about the value is a 3 and minus 3. Now what is the no change? It means you have to find firstly the direction of this. This is my I. You have to find any of the value. u2 already consider. Your target is to find u3 such that it will be 0. So what is the u1? u1 is my I and it's a 3 dimension. So I can consider u3 as simply j or simply k or simply I plus k, j plus k, sorry. Then clearly says that u1 dot u3 in each of the case is my 0. So it means this u3 is any of the vector direction are there. If I consider uj, then there is no change in the direction of y-axis. If you consider as a k, then again it's a 0. If you consider the linear combination of this, again it's as a 0. So that's why I said that when there is a no direction, there is not always a unique answer. Okay, look about the next type are there. So you have to find the derivative, that means the direction derivative. Again it's a 3 dimension, so you can write like here. What is that? You can simply take the partial derivative and at the point 1, 0, half, you can get this value. You can find this gradient, substitute this, you will get the answer as 2. Now here, this is the another type. Now in this case, you have to find the direction in which is it maximum, is it 14? It means you have to check whether this value, the direction of this value, can it be 14 or not. So firstly we can find its gradient. When it will be, now there is no direction, so you have to find the value of the direction so that it can be 14 or not. So what you can do, we can try to find the maximum value. If this is less than of the 14, then we can say there is no direction. What is the meaning of that? We can find the firstly gradient of this. What is the meaning of that? This is the maximum value of the gradient, but clearly says that this number is less than 14. What is the meaning of that? It means there can't be any direction whose rate of change is my 14, because this number is my maximum direction value. This is the maximum value, but this 14 is more than of this, so it means there can't be any direction. Look at the another type. So in this case, a function f is not given to you, okay, and your target is to find the direction of derivative of f in the direction of I minus j. So it means your target is to find this value. In this case, u cap is my I minus j over 1 plus 1. So u is already given to you. but what about the gradient of f? How you can find that, because f is not given to you? So this is another type. That's very simple. Your target is to find here. This is my u cap. Now how you can find this? So it's a two-dimension problem. So what is a two-dimension problem is there? It is my f upon xi and so on. Now if you take what is the gradient of f, this is my x of I cap over j cap. So if you take the dot product of this 1 by 2 here, so it means your target is to find the value of this and this. What is given to you? The derivative of this in the direction. So derivative of this in the direction of I cap. So I cap upon what is given to you? 2. And in the direction of this, in the direction of I cap minus of 2j cap over 1 plus 4 is given to you. This is given to you. Fine. This is given to you. Now from here we can find this value. So what is that? Gradient of f I can written as del f upon x I cap. I can write this value here. So what is the meaning of that? If you solve this value, what is the meaning of this? Gradient of f over x is my 2. If you solve this, gradient of f minus 2 times gradient of y, I can write this value is my 10. Now from these two values, can you find the value of this? So clearly say that this value is my 2, and from here you can substitute, you can get the value as minus 4. Substitute all these values here, you will get the right answer. Okay, look about the another type. So C, find the derivative of the functions in the direction of this. So what is the meaning of that? Your target is to find this case. It's a x, y, z, so it means there is a z also, because there is a 3 dimension. Can you find the partial derivative with respect to x? It is my here y of z and so on. At the point of 0, 0, 0, you can find this. What is that? This is the direction of 2i cap plus j cap minus of 2k cap divided by 4 plus 1 plus 4. That is my 3. So that is my here. Now take the dot product. What is that? It's a 3 to the 6 plus 0 divided by 3. Right answer is my 2. Okay, look about the another one. Now this is another type where the direction is given to you in the terms of the statement. So firstly you can find its gradient as usual. What is the u? What is the u vector? What is the meaning of the z axis? It means it will be in the form of k cap only. Okay, so it means this is my here. Once you know the u, then you can find this value as of here. So what is the value of this? This is a k cap upon 1. So now you can see this is a u cap. This is my gradient of f. Then you can find the direction derivative as 0 minus 0 plus 44 is the right answer. Okay, look about the another one. Now in this again you have to find the increase or decrease at the point P. So it's a 3 dimension again. We can find the gradient. We can find this. Now they are finding the direction. They are not talking about the find the derivative, direction derivative. So again the simple rule is f increases most rapidly in the direction of this and decreases in the direction of negative. What is the direction of this? This upon here. What is the gradient? That is my 2i cap plus 2k cap plus 1k cap over 4 plus 4 plus 1. And here is a negative sign is this. Fine. Are they asking about this? They are asking about the derivative value also. So what is the derivative value is? You can find the modulus value of this is my 3. This is minus 3. Okay, this you can do it easily. They are talking about the directional derivative. So that means they are talking about here. You can find the gradient from here. At the point of 2 minus 1, 1, you can find this. This the direction is given to you. So you can find the u cap from this value. That comes to be here. Take the dot product. You will get this as minus 11.3. 11 by 3. Okay, look about the last example. Now this is the temperature. The temperature in the 3 dimension is given to be here. A mosquito located at the point of 1, 1, 2 desire to fly in such a direction that it will get warm as soon as possible. In what direction should it fly? That's again the part of, because they are talking about the direction, so it means you are talking about the directional derivative. So instead of the F, they are given as a T, temperature. You can firstly find this way. Now you can see what is that. Direction is not given to you. What is the U? They are not given to you. What is the meaning of that? They are getting warm as much as possible. When it will be warm as much as possible, it means your temperature will be maximum. So what is the condition of that? That means F, or you can say that T, will increase most rapidly. So in what direction it will be increased most rapidly? So T increases most rapidly in the direction of gradient of the T. That's it. Like in the previous example, we're talking about the del of F. So the T will be maximum in the direction of the here. So what is the direction of this? This divided by here. Because they are talking about the maximum, that is, it's a plus. If they are talking about the minimum, then we can take as a negative P. So we can find this value. We can get the answer as here, because this is my greatest. What is the modulus of this? 4 plus 4 plus 1 is 2. So it means it will be moved in the direction of this. And the temperature value is my 3. So this is the way you can solve this and think about these directional derivative problems. I hope you can learn through various examples and you can try to solve the various problems by own. We will see the next lecture on the extreme values and the saddle points. Till then, you can simply follow my playlist Mathematics 1 channel named Dr. Harish Garg. I hope you can like, share and comment these videos. Best of luck students. Happy learning.